This is Duke University.
I'm Kyle Bradbury, Postdoctoral Energy Fellow at the Energy Initiative. Actually, a grad of both the Pratt School of Engineering and of the Nicholas School of the Environment. So I just finished up a PhD in that last year. So what I wanted to start with was an event in life that is very exciting for all of us: grocery shopping. So everybody loves grocery shopping. And what do you do when you go grocery shopping? So you go to the store, and you're walking around, you're putting things in your basket and getting all different items. Now, what if you, as you're walking around there were no prices on any of the goods you were buying? So you gather all of these goods together, you go to the checkout line, and they say, okay, come back next week. So at the end of 4 weeks, they finally give you a bill. Well, this is exactly what happens every month when you get your electricity bill. So you have no idea what the individual items that you're buying, that you bought every time you flicked the switch on and off. But nonetheless, you have to pay for all of them. So as part of a Bass Connections project, we've been exploring this particular issue. So let's get into this in a little bit more detail. So right now, we have a few buildings on campus that we're able to grab some data from. So we can take aggregate electrical power data from the Smart Home, which is a LEED Platinum dormitory over on Central Campus. Actually, Jim Gaston, the director of the Smart Home, is here with us today. We have Environment Hall, also another LEED Platinum building, the new home of the Nicholas School, which was just opened in the last month, and the K4 dormitory, which houses about 150 students and was one of the newer dorms on campus. So taking the data from there, we can read that data from a smart meter. So now, typically, you have your utility meter, which you get a once-a-month reading, as I mentioned, but these meters can read up to once per second. Much more information there that can tell you some really interesting things about what's going on inside that building. So what can it tell you? Well, if you apply data analytics algorithms, so now this would be machine learning techniques. So these are able to do interesting things on the data that break that aggregate signal down into device-level information. You can then get all kinds of information about how much energy you use for lighting, for air conditioning, for refrigeration. And this is actionable information. So now you see where all of your energy usage goes, but what does that buy you? Well, first of all, it can help you to reduce energy consumption. What if I knew how much electricity my refrigerator was using? It suddenly spiked. Okay, well, we're using quite a bit there. Maybe I need to replace my refrigerator, get a more energy-efficient version to reduce that. And it can also help increase cost savings. And there are a number of benefits that are associated with that. So if you start looking at time of use pricing, where you have a peak price, which is different from an off-peak price during the time of day, you can get benefits from this knowledge of knowing where your energy is going to across each of your devices. Additionally, there are utility interests in this and third-party interests in looking at demand response verification, energy efficiency measurement and validation. And all of these different benefits can be leveraged if we can do something interesting to these data that we're collecting from these on-campus buildings, from buildings that are being fitted with smart meters around the country, especially in California and Texas. So where's the Bass Connections component to all of this? So we, Richard, myself, Tim Johnson, Leslie Collins, Kenny Morton, Steve Palumbo, and I think that's about it for the leadership, came together last year, and actually I spoke on this last year at this event, talking about this idea for bringing together students to tackle this project. Now, why is this a Bass Connections project? Well, first of all, it connects a number of traditional disciplinary units into one project team. So we have folks from electrical and computer engineering, we have Nicholas School of the Environment folks, Energy Initiative, Public Policy, and Smart Home folks coming together to work on this. Now, why does it need these different components? Well, you have the technical piece, which is how do you actually do these machine learning techniques that break down the information from the aggregate into this disaggregated device-level information. But you also have to look at the policy barriers that are associated with this. and the economic implications of these types of technologies. So as we're going through this, we were very fortunate last year to have 5 amazing students work for us, with us, I should say. So from electrical and computer engineering, we had 2 undergrads, Abhishek Balakrishnan and Amy Wang, and they were able to make very interesting contributions in terms of designing a new dashboard, which is available now at energydashboard.oit.duke.edu, as well as create a small-scale test system for performing this analysis. And a PhD student from ECE, we had an MEM student from the Nicholas School, and an undergrad student from public policy, 2 of which, so the undergrad student from public policy, Sam Burston, he is going on to work for CIT Energy in New York, and will be, part of his ability to get that job was, he had mentioned, at least during his interview, this particular project. So over the, there have been a number of other benefits that have come from this, new classroom modules that are going to be implemented, new research collaborations. So we actually, through the work on this project, a new research partnership between electrical engineering and the Nicholas School came about, in which we submitted a grant to NSF. We'll see how that goes. And student competitions through Data Fest, as well as the Innovations Collab. So we're going to be going on next year with this project as well. And we'll have 6 students, 2 of which from this year will be continuing on. But I think it was a great success this year, and we're looking forward to what we accomplish in the year to come. Thank you very much.
I'm going to talk about our Bass Connection project, which, don't try to read this. Let me tell you right now, this print's too small, but it gives you an impression of what we're up to, and I'll go into some detail on each part of this. So this was a team of a mix of people from the Nicholas School, Dalia, Patino, Echeverri, Fuqua, Gavin Fitzsimmons is marketing, and I'm in management, and then 3 students who were from different places on campus. An undergraduate in psychology, Marie Kamori, Shajudi Hossein, who is an economics undergrad, and Gabe Goffman, who is an MEM student at the Nicholas School. So we essentially had a common question about how do you motivate people to be concerned about energy savings, and we did this in a couple of different domains with different ways of presenting information. But one common interest that emerged in our conversation was around focusing on energy use in food, because we found that we thought a lot of people didn't understand how much energy actually goes into food. And so this kind of breaks down into 3 different projects. The way that we ran the team was to come up with a set of questions together and then break it up and have each student try to pursue a behavioral take on that question. And if I think about what are the products of this collaboration, I do think one of the main ones is that the undergraduates are walking away with understanding the research process, knowing how you ask an experimental question and get rid of confounds, and probably even more deeply, they're really good at constructing surveys, which I hope can serve them both in their academic life and maybe after that, as well as analyzing data. So, and I have to thank Adrian for really being the kind of point person who ended up kind of pushing the students along all of those paths. So let me go into just a little bit of detail. All of this is going to be a flavor, maybe even an appetizer of what might have been interesting in the work that we did. And we have 3 posters outside where you can go into more detail if you want, and you can probably find Adrian or me to answer some questions about those. All right, so one of the basic research questions was around, if you just, in like a smart meter, get some information about how much electricity you're using and its cost, and you find out that it's a few pennies per hour, that isn't very impressive or threatening, and you might not do much about it. It doesn't seem like it's worth trying to change your behavior if you're getting that kind of feedback. So there's a lot of work that I've been doing, Adrian and I have been doing, on if you aggregate numbers to bigger levels, you can see more of an impact, and it makes it more motivating to want to do it. So yourself over a long period of time, like 100,000 miles of driving, which Adrian presented this morning, is motivating. Maybe we can also motivate people by telling them, if you and essentially 1,000 other people were to do this, this is the kind of impact you can have on energy savings or on CO2 reductions. And so in this project, Adrian actually worked with the Duke Green Devil Smackdown to give different messages to people who participated in it. We got everything moving in the right direction. not significantly, so it isn't clear there's an academic paper there, but they're at least heartened to see that things went in the direction that if you give people the big numbers, they seem more interested in changing their behavior. And then inside of the BASS team, Gabe did a number of studies just looking at giving people messages about reducing their meat consumption. So this little graph here just shows you an intention to reduce meals over the course of a week, how many meals you'd reduce by, as a function of getting information about the energy used in producing that meat. And so we aggregated essentially numbers about the energy savings over a day, which are the gray bars, or over 1,000 days. So we told them, you know, it's so many gallons of gas on a day, or it's so many hundreds of gallons of gas over the course of 1,000 days. So we aggregated either over days or people. And the main thing you can see in this diagram is there's a big impact of being told about if 1,000 people did it, you would essentially save this much gas. That is reflected then in an intention to want to eat less meat. So higher on this y-axis is an intention to eat less meat. So this is kind of a promising start to ways of kind of convincing people and framing things for them. Oh, and I've lost my timer because your screen went blank. Thank you. Okay. A second project looked at, do people have a good understanding of how much energy is used to make food? We modeled it after a PNAS paper that looked at, do people have a good understanding of how much energy is needed by different appliances to use them? So there's an actual energy use here and a perceived one which we've measured. The main thing that happens with, both of them are very flat, so people have a poor understanding of the relationship between actual and perceived. Food is shifted down. People way underestimate the energy that's needed in food compared to this identity line, which is the actual amount that's needed. So we're following up on that. And then one last project. We wanted to look at if you give people reasons for wanting to invest in energy efficiency, you can think about giving them an environmental one or money. And kind of we can look at the impact of single reasons on kind of persuasiveness. But then you can also think about combining them, either mixing one of each or giving people pure reasons in the same category, 2 environmental or 2 money. And one of the things that we've now found in a few studies is that for people who are not very familiar with the arguments, you actually seem to be better off giving them a pure message and a couple of reasons within that category than mixing both an environmental and a money one. And so anyway, we're in the process of trying to pursue that as well. So those are some of the outcomes that we got, and take a look at the posters outside. Okay, thank you.
Rather than thinking about, from a social perspective, the aggregate and broader populations, to hone in on and to think specifically about low-income populations, because that was the focus of our BASS Connections project. So what I want to talk to you about reflects work by a large team, including a number of undergraduate and graduate students, but also colleagues, faculty colleagues over in psychology and at Fuqua. And in addition to that, in addition to the Duke community that we were able to tap into, we were working with a local nonprofit, Clean Energy Durham. And so in terms of our deliverable, at the end of the day, we were geared towards trying to offer recommendations to Clean Energy Durham as to how they might better engage low-income populations in North Carolina and beyond. So I don't think I necessarily need to convince this audience of the opportunities that are there, but folks have started to get quite excited about opportunities that seem to be available in working with low-income populations and improving energy efficiency and energy consumption overall. And Clean Energy Durham has recognized this. They've developed a series of energy education workshops and materials for those workshops. But an issue that they faced is essentially how to get people to the table. How to get folks engaged in these energy education endeavors. And this is really what we ended up setting out to address through the work with students. So during the first part of the year, we spent a fair amount of time thinking about the available literature, but then we endeavored to look specifically at and to work with 2 different groups. On the one hand, a group of students went out and talked with owners and developers of buildings that would serve this population. And then we also had a set of students doing face-to-face interviews here locally in Durham with low-income residents, and I'll talk about those and what we found from those results here in just a second. With regards to owners and developers, we found really two major ideas. On the one hand, I think there's a misperception that for many public housing residents, for low-income residents, that they're not necessarily having to deal with utility bills. But in fact, we actually found that most of the owners and developers suggested that a lot of those costs are being pushed out directly to residents themselves, making energy education that much more imperative. We also found some of the reporting requirements for owners specifically in putting together gross rents reporting for loan applications could potentially be something that could be leveraged for residents themselves, because one of the things that we found in talking with residents was that they actually didn't have much of a sense as to what a typical utility bill should look like. They just knew that theirs was much more than they were able to bear and that it was much higher cost than they were happy about. So one thing that we tended to focus on was thinking about specific household level behaviors. And we looked specifically at weatherization behavior as a set of ideas that we might try to educate folks regarding. We know from other work that weatherization behavior isn't always necessarily just solely a function of attitude or interest in engaging in that behavior. Instead, there are questions that we might ask about housing situations, about other social factors, and those are questions that we wanted to raise in this particular instance with regards to low-income populations. And so in this particular case, we went out specifically and worked with social services in Durham County and got together a series of interviews, and I'll talk about those results just quickly in the few minutes that I have remaining. So just to give you a brief sense of who the students ended up talking with, we ended up talking with a wide age range of residents in the Durham area. These were all folks who were applying for the Low-Income Energy Assistance Program, but we were interviewing them separate from whether or not they ended up being awarded that assistance. Mostly, these were female and African-American residents who we're talking with. As you would suspect, this is a poor population. Many of these folks are renting their current residence. And we found that the situation is what you would expect in terms of energy efficiency. Most of these folks were reporting living in homes that during the past winter were drafty, most or all the time. And there was very little weatherization that had actually taken place in many of these residences, at least at the time since they moved in. So quite a bit of savings potentially to be had. We found that income mattered even within this particular group, and that those that were in a poorer situation were more likely to be living in a situation of draftiness. So let me just quickly talk to you then about what we found overall. We found substantial interest in energy education. So it wasn't a matter of interest or attitude towards energy education. In fact, the vast majority agreed that they would be interested in attending workshops like those that Clean Energy Durham presents. However, we found that those weren't really a common occurrence in the areas where these folks were. And we also were able to set out and look at what predicted engagement with workshops over and above attitude then. And we put together a couple of models predicting interest in free workshops or community meetings on this topic. And what we found were a set of predictors that might be a little bit different than you might anticipate. With regards to a community meeting, we found that, as you would expect, the average heating bill that one faced mattered quite a bit. It did drive interest. But it also mattered whether or not one saw their neighbor and friends and families as being interested in this as well. So descriptive social norms mattered considerably. And over and above that, we found that a personality characteristic, one's tendency to be able to plan for the future, what we are labeling future planning agency, that seemed to be predictive over and above attitude toward energy education. Similarly, for free workshop, we found that heating bill pressures were driving interest. But the perceived accessibility of information also mattered as well. So the degree to which one perceived energy as a topic that they could understand seemed to be predictive whether or not you'd actually have them at the table for this type of material. So just a quick summary then in terms of two thoughts that the students walked away from, and we all did at the end of the semester. There seems to be considerable interest here and considerable positive attitude towards energy education. And this is a group that is seeing high utility bills more than they can bear, and they are interested in getting help and assistance. That said, in order to actually outreach and engage with this group, It's going to be a matter of thinking about personal circumstances, reasons why people are not able to get to these meetings, and bolstering self-confidence in their ability to engage with this information. All of those are ideas that Clean Energy Durham is hoping to take to the next stage. So a couple of things to leave you here then to consider, but in the interest of time, I will step down and answer some questions here in just a second. So thanks.
I'm going to be talking about a project that was primarily with two students. Allison Donnelly, who's an undergrad Nicholas School student, and Christy Baudouin, who was a law student. There were a couple of other students we tried to have engaged that didn't really work out. We could talk about that at some point. And also Sarah Adair, who is on the staff at the Nicholas Institute, kind of also pitched in. And then I put myself and Tim and Brian Murray in small letters because we were advising. It's a very high faculty to student ratio, I guess. So this project was really motivated by the fact that when we look at petroleum refineries, we think they are most likely either next in line or second in line behind power plants to be regulated under the Clean Air Act. There are a couple of reasons for this. They're big emitters. There was also a court case that ended in a I think the term is a settlement agreement, that the EPA would regulate them, although that doesn't have a lot of compulsory element to it. And the EPA administrator has said she's not going after refineries. But it seems like eventually it'll happen. There's a whole process in the Clean Air Act, and when you regulate one thing, you have to regulate other stuff. So it seemed like if refineries are going to be regulated. We were doing all this work on power plants that you just saw earlier. And this seemed like an area where we could ask a lot of questions that nobody else was really even thinking about, because nobody else has thought about this question. And we didn't have a lot of pressure to do it, which is always nice. And the students really just kind of jumped in with both feet and both hands to really try to figure out what were the really important questions that the EPA was going to face and the stakeholders were going to face if we began to try to regulate power plants. And then there were basically two big things that kind of came out of that. One is a policy brief, and I'll talk about each of these in probably for 1 minute or something. Similarities and differences with the power sector. So there are similarities, there are differences. And then the key choices that the EPA is going to face can kind of be broken down into three pieces: the system of emission reductions, the format that they communicate the regulation, and then compliance flexibility they may or may not specify. So let me just spend 2.5 minutes talking about these two things. So when we started thinking about this, I think a lot of us brought to the table all of our thinking about power plant regulation. And over the course of the year, we kind of realized there were a lot of differences, and we decided, hey, other people may think the same thing. Let's write them all down. So here are a bunch of differences. Refineries are one of the largest sectors of emitting sources in the United States, but they are tiny compared to power plants, 2% versus 30%. Power plants produce a product that is only consumed in the United States, electricity. Refineries produce oil that is consumed elsewhere. We import it. It's a tradable good. Electricity has one product, electricity. Refined petroleum, there are thousands of products. Anyway, I could go down. Let me see if there's some really important things to point to you. Simple versus complex production facilities. You know, power plants are basically either boiling water to turn a turbine, or they have a jet engine that also boils some water and turns a turbine after it uses the jet engine to turn the turbine. Refineries are much more complicated. You've got these distillation units. You've got these things that break polymers up into big carbon change into smaller ones. You've got things that remove impurities. Really complicated, diverse, no one looks the same sort of thing. Another thing is that power plants are all over the place. Refineries are only in a few places. Power plants are in a regulated sector of the economy. That screen went blank. Can you make it go up again? Yeah, good. You know, the power plants are connected to their end users, and refineries are not. So there are a lot of differences that we just decided would be useful to write down. So hopefully that's useful for other people. And actually, we got feedback that people found that useful. The second thing that the group walked through was kind of the main choices that the refineries were going to face. And this has turned into a really useful exercise that we've turned into a working paper, which EPA is eager to see and the industry is eager to see. And it really breaks down into three pieces. These are actually the main conclusions we had. So the EPA has to determine what the system of emission reductions is that will define the stringency of the policy. And you can imagine a range of things between looking at individual little processes and the efficiency improvements they could get there, versus the whole system of refineries tackled with an emissions trading scheme, which could get a lot more emission reductions. EPA is going to have to make that decision, and it has a lot of consequence for how many reductions they can try to get. Similar to the power plants. Regardless of how it defines the system, it could suggest compliance flexibility, like trading, that the states might implement. And then I think what the most interesting thing that we came up with, or the students came up with in the course of the semester, was realizing that as different as these refineries are, and they're much different than the power plants, as I suggested a second ago, there are two real approaches to defining a standard that the EPA could use. One would be to have process-level standards, but allow the plant to basically bubble all of their emissions, so they only had to meet those process standards on average. And this would effectively differentiate every power plant to have its own unique emission rate standard. The other thing they could do is do some sort of historical baseline approach, which is popular in emissions trading programs, but has a lot less of a basis under the Clean Air Act, so might face additional challenges. So those two things really came out as really perhaps the most flexible ways to regulate the industry in a way that would accommodate the differences. Anyway, I think it's been really exciting, and we look forward to seeing what kind of response the stakeholders have to this report, but I'm pretty excited.
My name is Dalia, Patino, Echeverri, and I am assistant professor at the Nicholas School of the Environment. I'm going to tell you a little bit about the goals and the progress we have made so far in this project that is called Modeling Tools for Energy Systems Analysis, or MOTESA for short. I am one of the leading faculty members, but Nikos Pitsianis and Shobai Song are the other two. They are both from computer science and couldn't be here today. Nikos is in Greece, and Shobai is reviewing NSF proposals in DC. Our goal is, of course, to engage students across different levels and disciplines in research that sheds light on the problem of how to integrate renewable power into the US electricity grid. Any researcher that is trying to understand what are the potential and the effects of integrating different levels of wind and solar power has to spend time working on at least three things. It has to characterize the renewable resource, its uncertainty, its location, its cost. It has to characterize the conventional electricity generation infrastructure that is already in place. And third, it has to characterize the interaction and the coordination of the two by a balancing authority or an independent system operator. So we are trying with this project to help researchers by addressing at least two of these three problems. And we are developing tools that we would like to make accessible to students, to other faculty, and eventually to the larger public that are, have different levels of sophistication and different purposes, but that are all have in common that they can serve as building blocks that can be used in more complex models, and that it can be built upon them. So I'm going to talk about those two tools that we have been working on for the last year, and we continue to work this summer and the next because we got funding for a second cycle. So the first tool is called Synthesize. The objective of this, so we have two sub-projects. So the objective of this first project is to develop a synthetic time series generator of wind power, but also later of other stochastic processes that can be used as inputs in other models. And so far, what we have done is to develop this Synthesize tool that really represents the training series as measured by three metrics. So first, let me say, we are simulating wind power output data because this data is hard to come by. If you find that it's always for a very short period of time and is not at the time scale you wanted. For the time of research we do, we want it to be at very short time resolution, so 5 minutes or 10 minutes. We need to simulate it. And we need to simulate it, and we need to have it so that it replicates the same stochasticity of the original series as measured by the probability density function, that it replicates the autocorrelation function, so how it evolves over time, and that it also replicates how are the frequency and the magnitude of different ramping events. So like how often does the wind goes from not blowing to blowing at full capacity, or how the power output. So we have developed a user-friendly application that uses the model. It's a Markov chain Monte Carlo model, but is multi-regime and multi-order, and this cannot be seen, but this is essentially the first screen in the user interface. It allows users to choose their training series, the order of their Markov chain, etc. And then it shows them, it outputs in a file the simulated wind data, and it says, well, this is how the different metrics are for this particular use. Okay, and then the second tool is a variable energy resources stochastic market clearing. So what we want is to develop a model that mimics the models that independent system operators use to dispatch wind power and conventional resources. And we can do it both in the conventional way and also in a stochastic way, which means that we represent, rather than taking the expected value of demand, which is what is done today in the systems. So they take expected value of demand and subtract what is the expected value of the wind that is going to be blowing, and plan for that expected value with some reserves to react to what the real time is. We want to look at the problem from characterizing scenarios. So saying, we don't know, we don't care about the expected value. We're just going to look at these different scenarios of possible wind power and possible demand, and we're going to plan for that. So we have the model already. It includes it includes 3 pieces: the scenario generation, the stochastic day-ahead unit commitment, and the real economic dispatch model. And this summer we are going to develop with the undergrads and the master's projects and the master's students all the user interface. And thank you. I exhausted my time.
I don't have any background in energy, but because I'm co-leader on an energy project with Erica Weinthal, who could not be here. Do I have this on? Okay, good. I'll be presenting on our project. I will try not to get in trouble by trying to talk too much about energy sources, but I'll talk about it from my perspective and also give you a lot of insight into the learning that we did as part of the project. The project, Exploring the Intersection of Energy and Peace Building Through Film, was born out of a relationship with Eric Weinthal, Nicholas School of the Environment professor, has had long-term with the United Nations Environment Program. If you're not as familiar with the United Nations Environment Program, this is the youngest division within that program. This program is specifically created to assess environmental issues, which include a lot of times natural resources that are energy resources like oil, like wind, or like, see, I told you I'm getting in my comfort zone. In water, hydropower, charcoal, through timber industries. All of these factors, they look at those as playing a role in both promoting peace, or also being factors in rising conflict. So who controls the oil? Factors in environmental safety. Is there pollution around the oil refinery? Also human safety. Are there women going to the river to actually collect water for their cooking, for their livelihoods? And so if there's competition or challenges with pollution of the water, or if there's conflict around it, who is affected? So all of these can converge, and the United Nations Environment Program looks at these, does assessments of those particular areas, particularly after conflicts, not always so, sometimes after disasters, to ask the question, what are the issues at stake? Who are the people affected? What are ways that the management and the responsible management of these resources can affect greater stability in the area and greater health and safety? And so we took that information and particularly UNEP's goal, which was to find ways to better communicate these messages out to a general audience. They're complicated messages. They're very difficult to communicate quickly, which I'm going to try to do right now. But the way that they typically do it is they speak to policy makers. So they speak to governments, and they hand them a very thick book, lots of beautiful pictures, lots of graphs, but it's dense and it's very focused. And so their question is, we want to have a bigger impact. We want to increase the number of students, for instance, in environmental sciences and policy courses at universities. We want to actually impact people beyond just those who might be receiving our publication or downloading it. We want to find ways to really engage them and get them to think about these issues. How can we do that? And so this was a long question between Erica and the UNEP. And finally, one day, I'm giving you a lot of background to this, and then I'll move really quickly through the rest of this. But they said, essentially, we have all of our footage from all of these assessments. Let's see what you can do with those. And so we said, OK. Oops. And so there we got it. And so there, that's where I came in. So the libraries have a long history of receiving things in unordered, unknown contents, uncertain what can be done with them. Can we even do anything with them? And so we received all of this content, and our goal, in which we joined with the students to do this, was to say, let's figure out what's on this, what's usable, how can we organize this, how can we understand this in relationship to the UNEP reports. And so the students themselves had to very quickly get immersed into logging descriptions of what was on every one of these films, going through and essentially making data out of what was real-time video by going through and saying, this is what's happening, and this is what's happening, this is what I see. Asking this question, saying, when I look at this, what am I seeing? I've read the report. Can I connect that to what I'm seeing? Then they would also ask questions after they'd gone through all of that and gone through the reports and distinguished the issues, had to ask questions about who would understand this and who's the audience who particularly respond to this. Then, of course, after they did all that, they had to then edit this. Another task that's new, how to use Adobe Premiere Pro really quickly. How do you edit it down? How do you do overdubs? What do you choose to include? What do you choose not to include? Do you use your voice? Do you use someone else's voice? Is it okay if it's a high school student saying that? Do you need to find someone who has, you know, a more mature voice? Do you need to find someone of that community? And what's that very clear message that they're going to walk away with? So, success. We did actually produce an educational material. We have a film on the DRC produced by 3 undergraduate students, Leo Liu, Winnie Bewalt, who will be here later to talk about the project, and also Ellie Galt. Winnie's actually an economics major, so no background in either filmmaking or energy. But it was part of the challenge was also how do you communicate everything that you're seeing. The visual literacy all throughout. How do you connect that message? And the number one thing the students, I'll talk about this in lessons learned as well, they all said immersion and engagement was for them the huge takeaway, which was that they completely became part of that assessment, part of that video. When they then went back and had conversations with people who led assessments, like the scene from Nigeria assessment was a huge one. I'll have to talk about that later. Really being able to understand the message and the takeaways. And our big lesson learned was there was a lot that the students added to this. The not knowing was a big key for us in involving them. It was a very level playing field. We got a lot out of it, and I'm happy to answer those questions as well because I'm out of time. Thank you.